Alright, hey everybody. Happy Friday. Welcome to the last video on 3.2. We're talking about least squares regression lines, and we're just going to wrap everything up today. We're going to talk about what it might look like with a different, output. So what it would look like coming from Minitab rather than your calculator. And I do think this is one way you might see it on this year's AP exam, since they are saying that you can take the test without a calculator. So my guess is they would give you an output if they're going to ask you a question like this. We're also going to talk about briefly correlation, and we've already talked about how correlation doesn't equal causation. We talked about that back when we did Unit 4, but we're going to look at it again. Also, I want to apologize. My neighbors are mowing their lawn, so if you hear random lawnmower noises in the background, that's what's going on. All right, so this is what a Minitab outline would look like. So they might give you a little printout like this. They wouldn't have those colored boxes drawn in. You would have to know what they mean. But basically what this is this is a different output, just like when we would do in our calculator, we would do menu 414, and it would give us that printout and all those different pieces of information. This is just a different way to do it. And so the way this works is under coefficient, they go ahead straight off the bat and tell you the constant. That would be your y-intercept. And then the second part right here is going to be whatever your x variable is. And so next to that would be your slope. So the first thing under coefficient, the first one would be your constant. The second one is going to be your slope, and next to the variable that goes with it. So that's always your x. All right, then they also give you the standard deviation of the residuals, which we talked about yesterday. Remember, we talked about how that was a formula you weren't ever going to have to calculate. They would give it to you, and this is how you would get it. And then this is our r squared, which again, we talked about in the last video, lets us know whether it is a good fit. Now, this and these we will not use. The r squared adjusted we would never use, and then in this course, because we're truncating the material due to the shortened semester, that box that I just crossed out, that would have popped back up in chapter 12. But we're not covering chapter 12 material this year, so you don't have to worry about it. So everything you need to know from a Minitab output would look like this. And in the book, we've got some examples, and I will pull some extra examples as well for this one, just so you can see what they look like. All right, so in this situation, our LSRL would be y hat equals, and then first is our constant, our y-intercept, so 38,257, plus our slope, which is 0.16292, and then you got to put your x in there. If this data looks familiar, like I said, this is the info from when we did that Ford F-150 example in the first one. All right, then our standard deviation of our residuals is the 5,740.13, and then our r squared, they give it to you as a percent. You are welcome to write it as a percent. You can also write it like this, which is how your Inspire gives it to you. So they're both correct. It's entirely up to you how you would write that. Okay, so the menu 414 that we talked about in the previous two videos is the easiest and fastest way to get a least squares regression. However, sometimes they would ask you to do it without giving you the full data set. And you can actually do it as long as you have the means and the standard deviations of the two variables and the correlation, the R value. If you have those 5 things, so mean and standard deviation for each one, plus the R value, you can actually get your regression equation, which is actually kind of cool. I don't know. This is a new thing for me. I really liked it. So here are these formulas in the middle. The really nice thing is you do not need to memorize these. These are on your formula sheet. So yay for that. That'll be one of those things that as we start to review, we'll start looking at that formula sheet and really breaking it apart and knowing what you need from each of those sections. But those, like I said, those are on your formula sheet. So your slope is B. R is your correlation coefficient, Sy is the standard deviation of your y values. Sx is the standard deviation of your x values. And then to find your y-intercept, it's the mean of your y values minus the slope times the mean of your x values. Right, so it's relatively straightforward. It's like easy to number crunch. The only thing that would sometimes be a little funky is the numbers. So my guess would be if they were to give you a question like this year on the test, they would have to be nice round numbers because they're saying you can do this entire thing without a 4-function calculator. So just throwing that out there. All right, so let's work through an example of one. So we've got to investigate the relationship between foot length and height, both in centimeters. Data was collected from a random sample of 15 high school students. The mean and standard deviation of foot lengths are x bar equals 24.76 centimeters and standard deviation of 2.71 centimeters. The mean and standard deviation of the heights are y bar equals 171.43 centimeters and the standard deviation of y is 10.69. So the correlation between foot length and height is r equals 0.697. So they just gave us all that information. That's what we need to do to plug in. All right, so if we're going to find the slope first, slope formula, that's b, and that's going to give us r times sy over sx. So the standard deviation of y over the standard deviation of x. So r is 0.0697. Standard deviation of y is 10.69. Standard deviation of x is 2.71. When you mash the buttons in your calculator, you're going to end up with 2.75 for your slope. All right, then we need to do the same thing for the y-intercept. So for our y-intercept, it's a, and that formula is y bar minus b times x bar. So that does mean you are going to have to find your slope first before you find your standard deviation, just as a thing to keep in your head as you're working through this. All right, so y bar was 171.43. B we just found is 2.75. And then our x bar is 24.76. And then mashing the buttons in your calculator, you're going to end up with 103.34, and that's your A. So then you can put all of that together and write your y hat equation. So y hat is going to equal 103.34 plus 2.75x. And that's another way of getting a regression equation. So that works if you don't have your data. So if you have your data, the easiest way to do it, menu, type it all in, then do menu 414. If you don't have your data, then this is the way you would go about getting your equation. All right, so this last part on the back is just bits and pieces of things that we've kind of talked about here and there, actually all over the course for some of it, and it's just pulling it all together. All right, so the first thing we want to look at is correlation and regression, but you have to be, what they're saying is you have to be careful of their limitations because there are some issues with it. So the graph on the left and the graph on the right, they are the exact same data points, but if you look at the axes, what I've done is I've switched your labels. So in the first one I had miles as my explanatory variable, my x variable, and price as my response variable, or the y. And then for the second graph, the one on the right, I switched them. So now price is my x and miles is my y. And that actually drastically changes your standard deviation and it changes your equation. Your r and your r squared actually won't change. But you need to be careful. So make sure that you are clear, that you are in your descriptions, when you're reading from the problems, that you make sure you're not just like, I think that's x. Like, make sure you're actually following what they give you. Don't just randomly decide, oh, this is going to be x and this is going to be y, because it does make a big difference. Last videos, we talked about how correlation and regression describe linear relationships. And we said we looked at the residuals, And that was kind of our last defense to figure out if something was linear or not. And you have to look at that residual plot. If they don't say, use a linear regression, if they're just asking you to write the equation, you've got to go through and check with your residuals. And then the third one is talking about correlation and least square regression lines are not resistant. So we talked about resistance a while back in Unit 1. So it's been a minute. But when we're talking about resistant, we mean resistant to outliers. And when we're dealing with these types of data sets, we actually can have outliers in two different directions. We can have outliers in the x direction, and we can have outliers in the y direction. All right, so if we look at child 19, so that one up there. Child 19 is an outlier in the y direction. Its x is normal. The x value seems to fit all the other points. It's in the same area, but it's way taller than the rest of them. So that would be an outlier in the y direction. Child 18 down here, that's an outlier in the x direction because it's way far away. The next largest point is probably like 28 or 29, somewhere in that ballpark, and that child 18 is over 40 months. So that is much larger than everything else. So that's why that one's an outlier in the x direction. And when you look at these, right here, this is the original data with all the points included. If we take out child 19, which was our outlier in the y direction, our correlation changes a little bit, our y-intercept changes just a little bit, and our slope changes just a little bit. So there is some change, but it's not huge. But look at what happens when we leave 19 in and take out 18. Then it drastically changes. So without 18, the correlation coefficient drops. The equation drastically changes. So that's called an influential point because it drastically changes it. And that's what we're getting at in this next part down here. All right, so least square lines make the sum of the squares to the vertical distances to points as small as possible. Okay, we've talked about that. All right, a point that is extreme in the x direction. So if it's an x outlier with no other points near it, it's going to pull the line toward itself. And so that's an influential point. So your x outliers can be influential points. All right, your y outliers will not be influential points. All right. So your outlier could be one that changes in either direction. The x outlier is influential. All right, and then the last thing on here, we've talked about this over and over and over again. Yeah, I've used it in memes. We've talked about it in class. You've seen it in videos. An association between an explanatory variable and a response variable, even if it's strong correlation, is not good evidence that the changes in x actually change y. So we've talked about, there was a crash course video about that. We've talked about it before. Just because two things go along with each other doesn't mean there's causation. I actually picked up a book, actually it was over spring break when I got it. It's called Spurious Correlations. Correlation does not equal causation, and it's like 150 pages of spurious correlations where things match up, but they don't actually go together. So I'm going to put some examples of those up just so you can see. So that's it. I want to apologize for the lateness of this video going up. I had a hard time getting myself started on it today, and I finally realized why. This is our last new material, and I kind of didn't wasn't ready for that to happen. But we're not done. We're going to be reviewing for the next month. You're not done with me yet, but this is the last bit of new content. So before I close out, I just want to say I'm proud of you guys. This has been a fun year. This last month, maybe less so. But you guys have worked your butts off, and I'm very proud of you. And yay, we're done with new stuff. So bring on the review next week. If you need me, shoot me an email, and I will catch up, and I will see you guys next week. There will be a sign-in code that I'm going to give each of you for the online review course. So just like you got the code for the textbook, there'll be a code for you for the review course. So just keep an eye out for that getting posted. And I will see you guys soon. Thanks. Bye.